In this video, we are going to explain about a project titled Weather Prediction Using Machine Learning. Weather prediction through machine learning represents a pioneering and optimistic strategy with the goal of improving weather forecasting precision and credibility. By leveraging the sophisticated algorithms and extensive dataset, these machine learning models can discern the intricate patterns and association within the historical weather data, resulting in more accurate predictions. The integration of this state-of-art technology empowers the climate scientists to gain the deeper insight into weather phenomena, anticipate the extreme occurrence, and issue timely alert to vulnerable communities. This fusion of machine learning and meteorology holds the tremendous promise, potentially transforming the weather forecasting into an era of enhanced prediction capability and preparedness for weather-related challenges. And the aim of the project is to create an encompassing weather system by employing a variety of machine learning algorithms such as SVM with boosting, random forest classifier with boosting, linear discriminant analysis, Gaussian NB with boosting, and the voting classifier. By capitalizing on the unique strength of this algorithm, the project seeks to enhance the accuracy and the reliability of weather forecasting, leveraging the historical weather data. The system will uncover the meaningful pattern and achieve the precise prediction. Through the integration of the boosting algorithms to improve the model performance, the project endeavors to establish an advanced weather prediction framework capable of providing the dependable forecast and contributing to enhance the climate resilience and disaster preparedness. The basic requirements that are needed to build this project are software requirements: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB and hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the required Python libraries are imported to handle the data manipulation, visualization, and the machine learning tasks, such as NumPy, Pandas, Matplotlib, sklearn, and Flask are included. And the second one is importing the dataset. The weather dataset containing the information like date, precipitation, maximum and minimum temperature, wind, and weather conditions is imported. This dataset serves as a foundation for training and testing the machine learning model. And the third one is data visualization. Data visualization techniques are employed to gain the insight into the dataset characteristics and trends. Graph plots and charts are created to display the relationship between the various weather variables and observe any patterns or correlations. And the fourth step is feature selection. In this step, the relevant features are chosen from the dataset for building the weather prediction model. Features that have a significant impact on the weather prediction outcome are selected, which irrelevant and redundant features are discarded. And the next step is building the model. The first one is SVM with the boosting algorithm. In this step, the SVM algorithm is utilized as a base classifier for weather prediction. SVM is known for its effectiveness in handling both the linear and the nonlinear data. To enhance its performance, a boosting algorithm is employed, which involves combining the multiple weak learners to create the more accurate and robust predictor. The boosting process focuses on correctly predicting previously misclassified instance, iteratively improving the model's accuracy. This ensemble approach allows the SVM model to better capture the complex relationship within the weather data and achieve the higher accuracy in predicting the various weather conditions. And the next step is random forest classifier with boosting algorithm. Random forest is widely used ensemble learning method that combines the multiple decision tree classifier to form a strong predictive model. In this stage, a boosting classifier is applied to the random forest, further improving its predictive capability. Boosting helps reduce the overfitting and increases the overall accuracy of the model by combining the prediction of the multiple decision trees. The model can effectively handle the complex relationship and interaction between the weather variables and resulting in more accurate and reliable weather forecast. And the third one is linear discriminant analysis. LDA is applied as a supervised dimensionality reduction technique to address the classification problem. In this project, it is utilized to identify the most discriminative features that separates the different weather classes as of rainy, sunny, and cloudy. By projecting the data on the lower dimensional space, LDA simplify the model and enhance its performance. This reduction in the dimensionality allow for the better visualization of the data and can lead to improved accuracy in predicting the weather condition. And the next one is Gaussian NB with boosting algorithm. Is a probabilistic classifier suitable for multi-classification tasks, which makes it ideal for weather prediction with multiple weather conditions. To boost its predictive capability, a boosting algorithm is applied to Gaussian NB. By iteratively refining the model's performance through boosting, Gaussian NB becomes more accurate in predicting the different weather scenarios such as of rain, snow and clear sky. The combination of the Gaussian NB and the boosting creates a powerful predictor capable of handling the diverse weather pattern. And the last one is voting classifier. In this step, it is implemented to combine the prediction of previously built individual classifiers, namely SVM with boosting, random forest with boosting, LDA and the Gaussian NB with boosting. The voting classifier takes the majority vote among the prediction from these classifiers to make the final weather prediction. This ensemble approach leverages the collective knowledge of multiple models, leading to more robust and accurate weather forecast. The voting classifier allows the project to enhance the strength of each individual model, ensuring a more comprehensive and reliable prediction system for various weather conditions. And the next step is accuracy comparison graph. A graph is plotted to compare the accuracy of all the models used in this project. And the next step is training the model. The selected machine learning models are trained using the dataset. During the training, the models learn pattern and the relationship between the weather variables to make the accurate prediction. And the next step is user gives input. Here, a web application is developed using the Flask framework, enabling the user to provide the input for weather prediction. Users can input the relevant weather data for the specific date they want to predict. And the next step is the trained model is the given input is pre-processed for prediction. The user provided weather data is pre-processed to ensure it matches the format used during the model training. Data cleaning, transformation and scaling are performed as needed. And the next step is trained model is used for prediction. The pre-processed user input is fed into the trained machine learning model to make weather prediction for the specified date. And the last one is final outcome is displayed. The predicted weather outcome are displayed to the user through the web application. The user can see the forecasted value for the precipitation, maximum and minimum temperature, wind and overall weather condition for the day for the user input. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder. This is the code folder containing of various files within it. The static folder containing of the CSS, JavaScript, images within it. And the template folder containing of the HTML documents like of home, index, result, sign in and sign up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the model is a file that contains the information of the algorithm and that to be processed loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operations. And this is the dataset that we used in this project, And the weather prediction is an IPYNB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And to execute the project, we build the Flash framework as the front end. And the overall project code is in the form of code, output and graph as present in the weather prediction IPYNB file. And to execute the project, first we need to copy this code folder address and then open the Anaconda prompt. Here we need to change the location of the disk to F because our code folder is present in F disk. Then write a command cd space and paste this code folder address. By this, it will change the directory to the code folder path. And then write a command that is python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues. And then click on enter button. By this, it will run the app.py file. The Flash framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser. I prefer to use the Google Chrome and pasting this link and click on enter button. Here we get an screen like this. Having the sign up button, click on the sign up button. It redirected to the registration page containing of some details. These are need to be necessary filled. And by this it will create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of username and password. As to enter of username as admin and password too. And then click on the sign in button. Here it will redirect it to the index page containing of some necessary details that need to be filled. Precipitation as of 9.7 and the maximum temperature is of 25 and the minimum temperature is of 21 and the wind is of 7.6. And then click on the submit button. It predicted as the climate may be raining. And by clicking the back button and the refresh button, here we can enter the other details too. And I am giving the precipitation as of 0 and the maximum temperature is of 22.8 and the minimum temperature is of 17 and the wind is of 4.2. And then click on the submit button. Here it predicted as sunny. And this way we can predict the weather by using the various machine learning algorithms. In conclusion, this project demonstrates the power and effectiveness of using the combination of machine learning algorithms including SVM with boosting, random forest classifier with boosting, linear discriminant analysis, Gaussian NB with boosting and the voting classifier for the weather prediction. By leveraging the strength of each algorithm and employing the boosting technique, the weather prediction system achieved significantly improved accuracy and reliability in forecasting. This advancement in the weather prediction holds the great potential in providing the timely and accurate information to meteorologists, climate scientists, and communities at risk. The project's success highlights the importance of integrating the cutting-edge machine learning technique into meteorology, ultimately contributing to better weather forecasting and the disaster preparedness for a more resilient future.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.